Hi everyone, welcome back. So today I'm going to show you how to generate time series from NWM reanalysis data. And yeah, this time it may be reanalysis data or it may be real-time data. So I'm going to show you how to generate time series from NWM reanalysis. Basically, now these data are in archived. So I'm going to show you the time series for 2017 for Hurricane Harvey or for Storm Harvey that occurred over that Louisiana and the Texas sea area or that coastal area in 2017, and it was one of the major flood event, right, within in the history of USA or Texas. So you already have idea about how to download data from different archives, whether it is real-time data or even it is real-time archive data or even it is reanalysis data. Once you have the data, because these are the netcdf file and the data are for 2.7 million stream segment. If you know the stream ID, right, I'll show you how to download that stream ID, how to extract the stream ID for your location. I'll show you that in the next video. But now if you already have that stream ID, so how can you generate that time series, how to read that netcdf file and how to grab the variable you want. You want the velocity of a stream segment, you want the stream flow, right, the value of the stream flow. So let me just quickly share my screen here and I'm going to show you how to do that. It's not that hard, but you have to be patient over this one. Okay, so if I want to share my screen, it's that one. So I have the code I've written in Python. Yeah, you don't need all this module here that I imported because I just copied the header from the previous script. So what I'm gonna do here, I'm specifying that, okay, where I have the downloaded data. So I downloaded this data here, NWM Harvey. Okay, you can specify here or you can specify, I have this data. Okay, I'm using this one, NWM Harvey, that name of the folder. I'm just giving, okay, this is the input or download directory where I downloaded the netcdf files. These are the real-time files. You can use your these are the real-time. You can use reanalysis that I just demonstrated in my previous tutorial, and I also demonstrated how to download this real-time data as well. So what I need, I have to, because these files, right, these netcdf files, this contains Streamflow for 2.7 million, but I don't need all of them. I need the data where the Harvey event happened, right? So that's why I'm passing a file list or the list of stream segment here this way, com ID. This is called com ID, and these are the number for my location. These are the number, and I'm giving, okay, give me the stream flow. I'm just generating the CSV file, right? This CSV file contains the variables. Okay, the variables like this way. Okay, it will create at first the CSV file for this one. See, I have the same com ID and it just extracted the stream flow, it extracted the lateral flow, and it extracted the velocity. The variable I specified. If we have more variable, we have more variables, right? Now for reanalysis data. So for real-time data, we only have this velocity, stream flow, CMS, and lateral. So it is generating these variables for each of this specified com ID out of the 7 million. And what I'm doing after generating this CSV files, I'm just generating the time series, because see that CSV file is for one time step. See, you can see the date and time. It is for 2017 and August, right? 18 and 00, and then 1 hour, 2 hour, 3 hour, and then it is just going up to September. Okay, so that's that. So that is it is like netcdf file. I'm just subsetting. This is called subset. From that 2.7 million file, I'm extracting the variable for a certain number of stream ID. So that's what I usually do. Basically, these are for Texas or for that study area, but I need the time series, not right the data for time step. I need one single file for one stream segment, and it should be time series, right? So I'll do that, okay, here, and then I'm assigning, okay, that is the stream ID I'm giving. So subset the data, extract the variable for this stream ID, and later on, yeah, in the next part of the code will generate again, read all these CSV files, and it will extract one data from one CSV file, and it will make a time series, because that CSV file is for one time step. So I have to, if I want to generate the time series, I have to extract one data from each of this CSV file for one specific com ID or stream ID, and then I have to generate that time series. So that is the idea. At first I'm subsetting this data and making it simple, and I'm saving it in CSV files, but not in CSV file. I'm specifying the new name as CSV files test. So it will create one directory. If it is there, it will check. If it is not there, it will create one folder or directory, and then it will just start looping through the netcdf files in that NWM Harvey folder. Okay, and then what it will do, since it is .nc, the extension is nc, so it will check if the files are ending with .nc or not. If it is there, because I know it is there, so then it will just copy everything in a separate folder. So that's why I'm using this shuttle.copy command. It will create a new folder, and it will, by this name CSV file test, it will copy everything there, and then it will start reading each of this file, and then after reading, when it generate that CSV, it will delete that netcdf file, keeping the original file as it is. So that is the idea. So I'm just splitting the name as it is. So I'm just trying to because I have this NWM data in a this format. I don't want all of them. I need only the first part. Okay, and I want first part and the time. I want to add the time there, date and time, and I want to make the file like this. That's why I'm just manipulating here. I'm just splitting this one, and I'm creating, right, I'm adding the time, and I'm creating the file name here like that. It will be like year, month, day, and time, the CSV file name. I'm creating the CSV file name like this one, and then I'm just opening, because in order to open your netcdf file, you need that netcdf4 module, and then you have to use that method dataset if you want to use that dataset, because I imported that netcdf as dataset. So I'm using that dataset, and then I'm passing the name of the nc file and specifying the reading mode. So it will open, and then I'm just grabbing the Streamflow. So that is the command nc.variables. We know that, right? When I was showing another tutorial how to read netcdf file and how to read that mrms precipitation netcdf file, it is the same. You have to know the variables. That's why I just use ncdump in my previous tutorials to open what are the variables, right? Once you know the variable name, just provide the variable inside that quotation, whether it is double or single, and if you use this colon, means you are grabbing all this data, right, for 2.7 million. And for lateral velocity, and we are just grabbing the feature ID, means in that netcdf file it is feature ID, but I'm giving the ID as com ID. Okay, then what I'm doing here, I'm just closing the file. Once I have the variable name here, I stored everything, and I'm just making subset. Now that is the, I'm creating an empty data frame by the name com ID, because my CSV file has the same header name com ID. I'm just creating an empty data frame by the name of com ID, and I'm just using this variables, and it is just filling up that data frame, and it is creating a CSV file like that way. The first one will be the Streamflow. I'm adding the Streamflow first. The same name I'm giving there, right? The column name this way. So it will create, once the data frame is done, so it will subset, because it will create that data frame. This df data frame is for 2.7 million, because I'm just grabbing everything, but I don't need that. I need to subset it. So how can I do that? Because I'm passing that flowline.csv, right? Flowline that CSV here. I'm just passing that. Here I specified I wanna subset that CSV file for my case. So that's why I'm using that df, and that is the command. I'm passing this column name and dot is in dot, right, is in and com ID. If the com ID I have here, now from my here data does c ID, and then I'm listing the com ID from there. My list is this com ID, right? I'm opening that CSV file, and then I'm just looping through that rows, and I'm listing as com ID. That's why I'm just asking, okay, if I have the data frame that contains com ID for 2.7 million, but I don't need, I'm passing that com ID and I'm asking, okay, if that com ID is this com ID, so if it is similar, so generate another data frame. So this is how it is the command you have to know. It will subset the data frame, and I'm just saving this data frame and I'm getting that one. And now once I have this subsetted data frame, I'm just saving this one as new name. The name I created, that will be only year, month, day and time. And then it is removing because we copied the netcd file in our new directory. I'm just deleting it. Once the process is done for one file, it will delete, it will generate one CSV file, it will open next file and it will do the same thing and it will repeat. Once it is done, so I'm giving another list for which I want the time series. I'm passing another CSV file, and after generating this type of CSV files, I'm giving, okay, give me the time series, not for whole 1300 or anything. You can pass even 1 or 2 or whatever number you have. You can give this type of, the format should be this, object ID should be at the beginning and then the com ID. I'm asking, okay, give me this time series for this one, not for all of them. Okay, so when I'm giving this one, and it will again read this CSV file and it will list. That's why I'm passing another this for getting our time series, and it is even reading and it is creating that com ID list. Okay, com ID list, it is creating the list after reading this file, and it is generating the time series. It will create another test. Okay, test. So I'm specifying, okay, generate the time series inside the time series underscore rest underscore test. Okay, if the folder is there, it won't create. If it is not there, it will generate. And then what it is doing, it is just looping through that directory where I saved that CSV file, subsetted CSV file, right? So inside my CSV files underscore test, it will loop through that directory. That's why I'm just changing the directory there, and here I'm just I'm specifying the CSV out that directory, and it's looping through each of these CSV files, and it is opening the file and it is checking if my com ID is equal to the com ID inside that CSV file. If it is there, then even it is just generating a new name NWM underscore by the name of the com ID I'm giving. It is creating that one. So it is creating a new data frame the way it is generating, and yeah, the first column I'm creating the time, the date time. So that is the command. I have the list of date time. I'm reading the date time from the name of the CSV file, because the name of the CSV file, that is why I just assigned the date, right, for the name of the CSV files when I subsetted the data. And I'm reading the date, I'm getting the date from that one. So I'm just listing the date as well. After listing the date, I'm just generating the date time, empty date time data frame, and I'm adding the variables that I want, right here, list name, I'm adding that one, and then I'm saving as new name. So the new name for this case, it will be this new name NWM underscore, the file name means the ID of the stream, and then .csv. Okay, so if I run this, let me run this and let me show you. Okay, so what is the command for running that one? So Python, it will be NWM simulation time series maker, this code. Yeah, see, it's running, it's reading. See, successfully copied all these files. So where it copied test CSV file, see, it copied now all these files, it copied, and it is removing. See, it is generating that. It is reading each of these files, it is making the subset, and it is deleting the file. See, it is deleting and it is creating the CSV files. Okay, still it is generating the CSV file. Once the CSV files, the generation of CSV files are done, right, when it's done, then what it will do, it will start creating that time series, but still it is subsetting. See, it is subsetting, it is reading and it's deleting, it's creating the time series, not creating the time series, it is just subsetting this data. It is reading the netcd file, it is making the subset based on the stream ID I provided. And once it will be done, then it will start the process. We have to wait a little bit maybe, because the files are for maybe 1 month. We have because these files are pretty big, the system is fast. That's why what I do in my code, I specified, okay, reading this file and opening this one and created this CSV file, so we can easily monitor, right? We have, see, opening this file for 2017 and August 30, right? And for 31st, so for August is done. For maybe we started from 18th of or 22nd of August, right? And then 22nd of August to September, maybe September 10. So we have like 8 or 9 days remaining. So it's gonna, let me just check what is the last date we have. It is 2017 and August 4 or September 4. Okay, so September 4. Yeah, it won't take that much time. If I refresh it, maybe I'm done almost. Yeah, I'm almost done. See, I have only few files remaining. See, it's done. It's done. I have all these CSV files. Then successfully it's done. What it, see, start creating time series. So we don't have, does not match the length of that index. We have the problem there because it is not matching the index we need. It is not matching the file we need. It is a little bit different. That's why it is happening. So it is showing the error does not match length of index. It is 576 because we have issues in my code. I specified if these are not same. That's why I'm checking if these are not same, then give me the error. Okay, that's what I did. This happens sometimes because I changed this directory, or if I want to even extract. That's what I did. Basically, I have another code that will download at the same time. That will download and that will generate the time series. So this is another process. We can do that, and I have another one that will do the job. It will download. See, this one, it will download the real time, and it will do the job for us. Why it is not working? Maybe for NWM, I specified different file, or what was that? Let me check. Maybe we have different. Let me check it. So that is the download and CSV. Okay, we are keeping the CSV out from CSV test files to CSV out. Oh, maybe we have different folder. Let me just check it. Right, we change the name of the file here. Download directory is this one, and they are giving this one. Okay, let me just check it if it works. How? Okay, guys, I know what happened actually here. See, when I was just assigning the date time, because that's why I have different code. This is the previous version of the code. I assigned the date time here, so I have to have the data for this specific date time, because using that starting date and ending date, I'm creating the date time data frame here, right? But my data is not from 18th of August, right? So let me check. I have to specify that one. So that's what I thought. That's why I just created a single code, right, that can download and that can generate that CSV file and that can read. So that's why I have separate. So that code basically download and makes time series. Since I'm just making this video part by part, downloading separately, and then I'm showing that, okay, how to generate the time series. That's why it is a little bit different. So here is the data set. I'm using NWM Harvey. Let me check the data we have from August 22nd, right? And then what is the ending date? It is nothing but September 4 and 7G. I have the data for 7G. Okay, I'm just deleting that one for 7G. Okay, I'm deleting that part, or I have other one. See, NWM real time, that's from September to 10. Okay, so I'm gonna use that one. This folder has up to September 22nd to August 22nd to September 10. I'm gonna use that Harvey RT, that name, instead of other folder. So if I specify that one and the date is August 20 22nd to September 11 means I have the data for up to 10. So that is the way, because the way it creates the date, it takes, if I specify here left, see, means it will just create the date up to 10. So that is the command here. If we specify 11, so it will create the date up to 10. So that is the indexing system, or the limit. If we have a range, if you write any code like a range 0 to 10, it will give you the number 0 to 9, not the last one. Okay, so I'm saving this. I'm deleting everything, time series test, because it is not creating, that's why it is not matching, and test, I'm deleting everything. Okay, and if I run the code again, that code, so it is copying everything. See, it's copying test, RV CSV test. Okay, it's copying. This time definitely it should work. So that's why I have separate code. So while it is doing this one, I'm going to show you how to, the entire code that downloads. See, that is just I specified the date time here. So basically this is for that one. It is saving in NWM Harvey, and it is downloading the first part of the code, and then it started reading in a single file. I just combine them together, right? So that's why when I was testing separately, and then I make one code, and then I'm specifying separate stream ID, separate file for this one, and then it's just doing everything from download to time series, right? So let me just check if it see it pretty fast, right? This time definitely it should work. That's why you have to test your code, and I was trying to do multiple things and I changed it. That's why I'm just making this video, so that what is actually happening, and if you have any error, if you won't have that, right, if you wouldn't have that error, so we wouldn't be able to identify that, okay, we have to even check the time, right? When I was writing the code, I checked it, right, because I wrote this code like 2 years ago, and I'm just creating this video now, right? So even I forgot what I did. That's why I need to write some comments. That is the standard way. Sometimes I do, sometimes I thought, okay, I can remember everything, but really I don't. So I think we are almost done with that CSV generation. It is almost, see, it is up to it is haphazardly just creating these values, so but it won't take that much time. It's almost done, and once it's done, then definitely we'll be able to read. Sometimes it is the server, depends on the server. Let me check how much processor I have left. I can check that. Yeah, it is empty out of a 88 processor. I'm just only person. I'm just running. Other person, they're not running that much. There is only another guy who is running. Okay, that doesn't matter. So here it is processing. It is up to September. I have several files. It's almost done. It's almost done. Let me see. So you can try, you can write your code, and you can make your code more efficient. So at the very beginning, you may not be able to write that way, but when you'll know, okay, that is the processing, and you need to create that specific code for your own purpose. So maybe I'm doing for my purpose, that serve my purpose, right? It may not serve your purpose. So it is done. See, it's done. So what it is doing now, it is just reading each of these CSV files, and it is creating the empty data frame first based on the date time, starting and ending date time, and then it is creating an empty, it is filling off a list of Streamflow, velocity, whatever variable I specified. See, NWM for this one has been created. That's why I specified when it's done, it will show me that, okay, what is happening. So here, time series test. So see, it is the same file, and second one, it created another one, see. And if I open, it is the time series for my, see, this is the time series. The first one is the date, and I have the time value of Streamflow. So if I want to plot it, because I have another code that can plot, but it will take a little bit time, but I don't want to spend time on that. Okay, so here it is. If I want to select and see, that is the Harvey. See, it looks like a hydrograph, right? Definitely it is a hydrograph. So from that netseria file, from out of that, see, out of the 2.7 million stream segment, we're just getting the hydrograph for our specific stream and location if you specify the stream ID for your. So that's the way, right? You can do that. These are the processing. You have to be able to understand all this code coding and other programming, and this basically the file system where they have stored their files and how can you download that one. Once you have your file, what are the variables you need, and after that, right, how to make time series. And when we have the time series right now, so what you'll do with this time series, so you know the location, right, where you are extracting your data, and if you have this information and if you have your observation data, you can compare. So these are the simulation data, right, and you have the observation. If you compare them together, so you'll see if it is matching or not, and then you can calculate the validation statistics like RMSE, the correlation coefficient, the Nash-Sutcliffe coefficient, NAC, and you can also calculate the mean error, right, mean absolute error and percent bias and everything, right, and variance and standard deviation. You can do everything, and then based on that information you can say, okay, the model performance is this and that is the error of the model. If the model has higher biases, definitely the NWM model, it has higher biases, so you need to correct the bias. So in one of my paper, journal paper, so I did that one. So I tried to correct the biases of NWM, and then it improved the simulation. It was missing, right, better with the observation. So if I have that suggestion, so then they will implement, okay, we have the higher biases because the model may underpredict or may overpredict. So what we have to do, we have to reduce the overprediction, or we have to improve the underprediction so that it can better match with the observation, right? So that's why people are just trying to test. It is not for one specific location because it is covering whole of USA, and they have different land because they are using land surface modeling, right, LSTM. So because of that one, you have to use the soil moisture accounting model as well, because this is the hydrologic model, and they're trying to change different parameters to calibrate their model and to better match with their observation. So this is how we have to know all this processing from download to time series, making time series. And in a separate video, I'll show how to even calculate if you have many observation points, like 1,000 or more than that, and you have that observation location as well, and you have the simulations. How can you even calculate that RMSE, everything in a single command? So I have one script, I've written a code in Python, so that will give you the statistics, right? The validation statistic, everything like that way. Okay, let me just quickly show you again, and then I'll be done. If I can show you that one, let me here. Okay, so it will give you that statistics. I created that one for wind, and here's that. Okay, validation statistics, val statistics. Okay, here it will give you that for this one, for observation and ACE warp. Okay, I have this number of stations. These are the stations, right? These are the stations, almost 100 station, right? Almost 100 station. What I'm getting here, I'm just showing you that in that format so that you can see. See, I have these stations. These are the name of the stations, and I'm calculating mean absolute error, and then mean square error, and RMSE, root mean square error, and then R squared, right, the coefficient of determination, and then the Pearson correlation, then NAC, then P bias, and standard deviation, and variance, and sample variance, and the observation variance. So once you have the data, because it is impossible to even click one by one and to calculate all these parameters, so you need code, right? So it will just do the job for you, and then it will basically write a CSV file in that order. And once you have the CSV file, you can analyze the data, and you can write your paper, or you can even interpret. You can write your report, and you can interpret the result and the performance once you have the statistics. So that's that. So I'm not gonna even extend the video anymore. So I think, yeah, if you are gonna reproduce everything, you'll learn a new thing, I guess. And if you have any query or question, you can let me know. I'll try to answer that question, or everything is there in the website. You can figure it out by yourself as well. So thank you very much, and thank you for watching. Stay safe, and see you in the next tutorial.